So what's happening here is something called the central limit theorem. The central limit theorem tells us that if we take a random sample from the population, if the sample size is large enough and the population size is larger than the sample size, then what we get are, and I'm going to highlight this part because it's important, the sampling distribution of P is approximately normal. And aren't we seeing that below, right? Normal distribution, normal distribution, normal distribution. The mean is the same P, right? Notice that the middle of these is always 0.5. It's the same for all of them. But what's changing is the standard deviation, right? We could just see as we move from left to right that the standard deviation is getting smaller. It's getting more and more narrow. But this theorem is saying, you know what? That standard deviation, we actually have a formula for it. We can figure it out. Okay. The important part about the central limit theorem is that the mean stays in the middle, regardless of how big our group is. But the bigger of a group we take, the tighter that histogram is on the center. So let's actually figure out what this standard deviation is. And we actually call it something different. So this is another important part of this video. When we're talking about standard deviation for a sample, we call it the standard error. Okay, so this formula up here, this is the standard error formula, which really just means it's standard deviation, but we're talking about a sample, we're talking about a group. So let's do n equals 2 first. So the standard error in that situation is going to be the square root of P. Okay, now we need P. I need to know what the proportion of people who liked avocado was out of the whole class of 32. In this case, the class was evenly split between people who like avocados and people who don't. So P in this case was 0.5. That means that 1 minus P is also 0.5. So here we get 0.5 times 0.5. But on the bottom of that, we divide by the size of the sample, which in this case is 2. Now, when we put this into a calculator, we get 0.35. Now let's do the same thing for n equals 4. So the standard error here is the square root. Again, P is the same, 0.5. 1 minus P is the same, 0.5. But now we're dividing by 4. And when I do that, my standard deviation is smaller. Now my standard deviation for the sample, we call this standard error, is 0.25. And looking at these two graphs, that should make sense because this one's more spread out, so it has a bigger standard deviation. This one is less spread out, so it has a smaller standard deviation. Now, we're going to do the same thing for 8 right now, but I bet you can make a guess that that standard error should be even smaller. So standard error for a sample of 8 is 0.5 times 0.5 over 8. When we put that into a calculator, we get 0.177. So even smaller. So now we can see that as our sample size gets bigger, right? As the sample gets bigger, the standard error gets smaller. And that's a key idea of the central limit theorem. So the central limit theorem has two pieces of information. One is this part about how the standard error gets smaller. The other is that that average stays in the middle, right? We expect the average of the whole group to be the same as the average of the sample.